Hello, this is Singtek Lee from Physics 2212, and this is my lab report 1. The purpose of this experiment is to determine approximately how much excess charge is on one piece of charge-clear tape. So the fundamental principles I'll use for this experiment is the gravitational force of Newton's law, which is F equals ma, and in this case, acceleration is considered to be gravity. And by using Coulomb's law, I'll calculate the electrical force, which equals to Coulomb's constant K times Q1 times Q2, which is the charge of two objects divided by R squared, which is the value of the distance between the two objects' square value. And by Coulomb's law, we can also know that the like charges repel and the opposite charges attract each other. And also, I'll be using the law of equilibrium. To give a brief overview of the results of the experiment, electron deficiency was confirmed due to the positive charge of the tape. The experiment's goal is to observe the interaction between the two U-tapes, and the assumptions I made for this experiment is the charge for two U-tapes are equal in magnitude, and that the two U-tapes are both neutral initially. And I also excluded external physical factors such as air resistance, temperature, and humidity. For the experiment model, tape B is the system, and tape A and all the environment surrounding is the experimental surroundings. The tape mass that I measured is 0.0002 kilograms, the length is 0.2 meters, and the width is 0.02 meters. The observation results I got from the experiment is that the distance between the tape A and tape B I measured is 0.03 meters, and the tapes repelled each other and was attracted to negatively charged objects like a pen nearby. And by this observation, I concluded that the tapes are positively charged. And by these observation data, I could calculate the amount of charge on one U-tape, and before the calculation, I also made some assumptions, such as I considered that each tape has a single point charge located in the center of the tape, and each tape has the same net charge, and I excluded air resistance as its contributing factor. Firstly, the magnitude of the gravitational force on the tape B can be calculated by the Newton's gravitational law, F equals mg, which is 0.000196 newtons, and the magnitude of electrical force on tape B can be calculated by using the law of equilibrium. And in this case, the magnitude of the gravitational force is equal to the magnitude of the electrical force, which is 0.000196 newton as well. And the charge of the tape B can be calculated by the modified version of Coulomb's law, which is in this case 1.4 e to the power of minus 8. And the electron deficient can be calculated by this charge on tape B divided by the single electron's charge. And this can be calculated to the result of 8.75 e to the power of 10. And the number of atoms on the tape can be calculated by using the area of the tape divided by the area of one atom, in this case calculated to 1.273 e to the power of 16. And the deficient electron to atoms ratio is calculated to 6.8722 e to the power of minus 7. And these calculations I showed in the previous slide can be expressed similarly in VPython code. And as you can see, the initial values are same to the observation data values I got from the experiment, and the equations I used to calculate is equal to the equation I used in the previous slide. And one thing to mention is that I made a function called e-force, and this e-force function takes in two parameters, tape 1 and tape 2, and returns a value of e-force, which stands for electrical force. And this electrical force lets us estimate the amount of charge on each tape necessary to float one tape above the other. And if you look at the left-hand side of the image, there's a red arrow pointing upwards, which represents the e-force, and the green arrow represents the gravitational force. And these arrows are equal in size due to the law of equilibrium. And the magenta-colored sphere represents tape B, which is floating, and the blue sphere represents tape A, which repels tape B to make it float. For the discussion, I'd like to talk about the differences between model predictions and actual data. Considering tapes as a single point charge interacting with each other made a difference, and the charges of individual tapes also may not be equal for the model and in actual data. And errors could happen in experiments such as external physical conditions that are excluded, like humidity, friction, and temperature, and there could be inaccurate measurement due to human error. And there could be a possibility of lost charges as well when movement takes. I'll finish my lab report by answering what if and why questions. For the first what if question, I think the results would be the same since the Coulomb's law would not be different by changing the characteristics of electrons and protons. And for the why is question, I think by touching the tape, one might have to risk it to be discharged, which this will lead to affecting the results. Thank you.